Least common multiple is the thing that is most frequently confused with factors. So I'm going to do my best to try and compare so that you know the difference. Factors. These are numbers that when multiplied, okay, when multiplied, produce a specific product. Okay? Okay? Factors of, let's just say, 16. 1 and 16, 2 and 8, 4 and 4. Those are the factors of 16. Would you agree with me? Okay, hopefully I didn't skip anything. Factors of 18 include 1 and 18, 2 and 9, 3 and 6. They share the 1 and the 2, right? These are the factors of 18 and 16, right? Tracking with me so far? They share the 1 and the 2. The greatest common factor looks like it's 2, right? Mm-hmm. Because it is the largest.
No, 6.
I'm sorry, you're right. Wait.
Oh, my bad.
6 is not a factor of 16. Thank you, dear. Okay. So far, so good? Those are factors. Factors are the numbers that create a product. Okay? Multiples. Multiples. These are products created by a number. Okay? Multiples of, let's start with 2. Multiples of 2 include 2, 4, 6, 8, and I could probably continue until I turn purple. Right? How about multiples of 6? 6, 12, 18. Okay? 6, 12, 18. Unlike factors, we are not going to discuss the greatest common multiple because, holy cow, that number can be an infinitely high number. We are going to discuss the least common. Notice that the least common multiple is the first multiple shared by 2 and 6.
We have praise team A to the Josias, praise team A to the Josias.
These are multiples. Okay? Huge difference. If you tell me the least common multiple of 2 and 6 is 1, I want to ask you, what can you multiply 2 by to get a 1? 1/2. What can you multiply a 6 by to get a 1? 1/6. Those aren't shared. They don't have those in common. That would be perhaps something about factoring. But multiples are numbers that are a times table, so to speak. 2 times 1, 2 times 2, 2 times 3. Okay? Factors are the items that, when multiplied, create the product. Okay? Y'all need to figure this out and get it under control quick, because this is going to be a critical juncture for you. Example 1. Looks like they're showing crops here. Example 1. First of all, they talk about agriculture. In agriculture, we do not plant tomatoes on the same spot every year, or corn, or beans, which happens to be the stuff most often done here, right? We do, however, rotate our crops, and that is because certain bugs that are attracted to certain things are not attracted to the other. So let's just say I plant tomatoes this year, and then a bunch of tomato beetles come, and then do their thing, or tomato worms, and then they go into larva and pupa phase, and then they hatch next summer. They're going to want to eat tomatoes again, right? But if I plant beans on that property, they will die because there's no tomatoes for them to eat. All right? That's why farmers do not plant the same crop year after year. Those of you that live in farm fields probably notice it. One year you'll see corn, the next year you might see beans. You might even see a field rest. All right? Take a gander at the agricultural chapter, or paragraph. Suppose a farmer grows alfalfa in a certain field every 6 years. In another field, he grows it every 10 years. This year, he is growing alfalfa in both fields. After how many years will it grow in the same field again? Remember, he grows one every 6 years. So the 6th year, the 12th year, the 18th year, the 24th year, the 30th year. Okay? Then the other field, he's doing it on a 10-year rotation. So the 10th year, the 20th year, the 30th year. What is the least common multiple of both of those is going to be the year wherein alfalfa is in both of those fields again. And that's what example 1 asks. Let's take a look at example 1. First of all, they say in order to describe this crop rotation as it sits, the number of years will be understood by the least common multiple. Okay? They show 2 ways of doing this. First, you can list the multiples of 6 and 10. Which I've already done in when I said it to you. So 6, 12, 18, 24, 30. I'm going to quit right here and hope that I get somewhere quick, and I know I will. 10, 10, 20, 30. This is the first item they share. Okay? The least common multiple of 6 and 10 is 30, which means 30 years after the first time they're in the same spot, they will again be in those locations. Okay? This is one way of doing it. Another way of doing it is to find the common factors and use that for multiplication. So I'm just going to show you really quick this method. 6 and 10. Prime factor really quick. 2 and 3. 3 and 1. 2 and 5. 5 and 1. Okay? First, highlight what they both share. What do they both share? They share the 2. Okay? This is shared. But they also have a 3 in one of them and a 5 in the other. So whatever's shared gets listed one time, and then anything that's present in the list of factors gets included. This will give you the least common multiple. Okay? Whatever's shared gets listed one time. If 2 2s were shared, 2, 2, 2, 2, you would list 4. Okay? Because 2 times 2, or 2 squared. Hopefully I'll have another example that I can show you that looks like that. Okay? In any case, This technique is a little quicker, but some of you might not grasp it, so I'll try and show it a little further. That's example 1. The checkpoint, I want to do example 2 with you. Bottom of the page. I'm going to do example 2 and example 4. Checkpoint 2. What is the least common multiple? Well, method number 1 is you list them out. Method number 2 is to prime factor them. This is that new method that you may not recognize, that you may not understand so well. I'm prime factoring my 20. And I have found that 20 is 2 times 2 times 5. 25. 5. 5. Okay? 5 times 5. Okay? What is shared? 1 5 is shared. Right? Would you agree with me on that? Okay? One of the 5s is shared. Also present and in attendance is an additional 5 and 2 2s. 5 times 5 is 25. 25 times 2 is 50. 50 times 2 is 100. Therefore, the least common multiple is 100. I could write this out for you by listing the multiples. 20, 40, 60, 80, 100, dot, dot, dot. 25, 50, 75, 100, dot, dot, dot. Okay, I like this method because it's faster. You may not. Checkpoint 4. And I know we're running short on time. I'm sorry. Checkpoint 4. 15, 30, and 50. 15, 30, 50. Least common multiple. First, we're going to prime factor it. 3, 5, 5, 1. 2, 15, 3, 5, 5, 1. 50, 2, 25, 5, 5, 5, 1. So the prime factorization of 15 is 3 times 5. The prime factorization of 30 is 2 times 3 times 5. And the prime factorization of 50 is 2 times 5 times 5. What do they all share?
5.
They all share a 5. I'm going to highlight it, and it gets listed once. Okay? So far, so good? What else is present? A 2? Oh, yeah. Nope, they don't all share. Hold on. I'm just counting to make sure. One 2 is present in both of them, but not all of them. Okay? Another 5 is present. And then a 3 is present in 2 of them. Okay? You only list it as many times as it appears in more than one factor. Yes?
So, like, why'd you write 1, 2, and 52 if they don't all share the 2?
Say it again, please.
They don't all share the 2, so why'd you write 2, 2, or 1, 2, and 2?
Because in order to create any of these numbers from this list, at least 1 3 has to be present. Because this guy has a 3 and this guy has a 3. Okay? So it's only in there once. In order to create 15, 30, or 15 from these multiples, from these factors, see I even said it wrong, you need at least 1 2. Okay? And they all shared a 5, which was what I started with, but one of them also happened to have an additional 5. Okay? So this is what they all share. This is the number of this particular factor. The number that is the max in any of them. Okay, so the max number of times the 2 appears is once. We list it once. The max number of times the 5 appears after the common one is once. The max number of times the 3 appears in any of these is once. Okay, so this is what they all share. This is the max appearance of any of those within this list. Okay, I know it sounds tricky. All right, I know it sounds tricky. Multiply that out and you're going to have 150. Shoot, I went over. Oh well, 150. Okay.